Alright, hello mathematicians. I'm just going to talk you guys through a few of the basics for your assessment. If you're struggling to get started, this might help you out. So the first thing most people want to do is create a chart that compares fat in an item and the energy content in an item. I've spoken about this a little bit in class, but works best if we have, so the fat is sort of dictating the energy content. So if we have the fat on the left hand side, and it's our first column we select, and our energy on the right hand side. So I'm just going to paste these two values out. That is my energy, copy that. That's my fat. Beautiful. And so what we've done is just switch around the order there. So we've got fat, then energy. Over here we had energy first and then fat. I'm going to create a chart from that. I think most people are pretty confident with this part. Create a scatter plot. Fantastic. Now we have energy on the side here, fat down the bottom. You can throw a chart title in. This handy little icon, which should be the same for most versions of Excel. Be able to add a trend line or axes labels. If you're going into your trend line as well, you should have more options down here. There's a few ways to get this as well. This is just one way that I might show you. We might display the equation as well. Now this equation gives us two things. It'll give us our gradient and our y-intercept. Your gradient's pretty important for, I think one of your questions lists what is the gradient of your chart, or of your regression line, sorry. And you'll use that whole equation to calculate a future value. Now it's also got your R squared value, which if you weren't here on Friday, I had a little talk about R squared value. I'll add the R squared value, but we don't necessarily want it because we want an R value. We want correlation coefficient, which is not this R squared value. So if you've got this on here, we just want R. So you can actually square root this number. So put this number here of 0.8809, square root that, and you'll end up with your correlation coefficient. Okay, it's very important that this shouldn't really belong on your assessment here, this R squared value. So as a result, I'm going to get rid of him. I'll show you quickly how to perform a correlation coefficient as well, because I think it's probably a little bit more basic. So we want to do a correlation coefficient calculation on energy, on fat and energy. This is the value that lies somewhere between 0 and 1, or 0 and -1. 1 being extremely strong and extremely well correlated, 0 being virtually no correlation. So look, we're expecting to see some correlation. I'm going to start typing a formula here. I'm going to start typing correlation. Hopefully you can see that. C-O-R-R, and that's already suggested it. And double click on that. My array, as in what data set do I want to compare first, is going to be my fat, and then my second data set that I'm going to do. Oops, I didn't do that correctly. My apologies. My first data set is going to be my fat, and then I'm going to hold control down, and I'm going to highlight my second data set, and I'm going to press enter, and I have a correlation coefficient of 0.93. Very strong. Okay. You will be talking about your correlation coefficient, and a strong or high correlation coefficient gives us confidence in predicting values both within our data range and outside of our data range within reason as well. So now, this is a big part already here. We've created our chart, we'll label it, I'll let you guys label it of course, we'll add units of course, and we've got our correlation coefficient here. Now we can use this data to start answering some of those questions on our assessment sheet. We've created one here for fat versus energy. You also will be creating one for carbohydrate versus energy and protein and carbs as well. Couple of little bits of troubleshooting. Really important, the first thing I want you to check is that your equation here, y equals mx plus b, has to have a positive value at the end here. So this is like, for example, positive 280. If it doesn't, chances are that means you've got your axes labels flipped, which may not seem like the worst thing in the world. It may make sense as a chart. It may seem, like there's some sort of pattern there. And your regression value will still make sense as well. But when it comes to calculating like future values, like there's a question there that says, all right, how much energy would you expect in a meal that had 8 grams of fat? If it comes to subbing in your 8 grams where your X would be, you'll end up with a really small value or potentially even a negative value, okay? Which is not true. So I might even just do this one really quickly. I wonder if I can pull up a calculator online. Let's do that. Calculator online. Beautiful. Where were we? Few tabs going on. So 66.17. I reckon I could probably copy that. Oh, geez, can I? What I'm doing here is just giving you an example of, no, I can't copy that, of that calculation where it asks you to calculate based on 8 grams of fat, how much energy you would expect. So we're going to go 66.167 into our calculator. Couple of tabs. 187 multiplied by 8. Okay. And then to that, we're going to add our y-axis value, which I believe is 280.27. Gives an answer of just over 809 kilojoules. So what that value is there, that's your expected amount of kilojoules in a meal that had 8 grams of fat, okay, per 100 gram. So if you've got 8 grams of fat in there, then you should have 809 kilojoules. Well, that's our expected value. If we head back to our chart, that checks out too, because along the bottom here we would have fat in grams. And so this is the really important part that you want to sort of fact check yourself and go, okay, yes, my calculations match my graph and are realistic. So 8's going to sit about here, 8 grams of fat. You go up to our trend line and look, if we're probably equal with, about that 800 there. Well, we certainly are. We should be. So you want to be looking at too. So just for reference as well, have a look over here and go, all right, look, these are pretty close to 8. We've got like 7.5, 7.7, and they're all 600, 700 kilojoules of energy in there. So double check yourself and go, all right, if it's 8 grams of fat, roughly what do these other meals have, okay? Because if you're getting an answer of, say, -10 or an answer of like, 5 kilojoules or 27 kilojoules, a really low answer, that's not realistic, and you know full well that you've gone amiss somewhere. And it may not be in your calculation; it may just be that your entire formula was incorrect to begin with. So that's the big part. Created chart, created our regression line. Our correlation coefficient from that. That's our regression line on there. And we've remembered to order them from the start. Send your drafts in, of course, and if you've got any queries, let me know and we can, get them sorted. Good luck, guys. Best wishes. I'll be contactable, for a long time all weekend. So get onto it.